If you haven't, if you saw earlier, we have a like Slack channel that it's not just, we've been giving that out to people just wherever we see meetups and things. It's more like a community. It's not restricted to just like this Utah County data science. So if you have anybody who's like, oh, you like data science, I'm in Utah, then feel free to exchange that information. So it's we've got the Roku app. So if anybody needs that link again, I can hand that out or whatever. So any announcements that anybody wanted to throw out before I get into some?
No. So I talked with, once again, the Python meetup at the point. It's happening right now as well. So they switched organizers this year. So I had talked to the new guy, but I was curious how many people might be interested in going to that meetup also. If there's on a different day that wasn't at the same time as this. And so there's enough of us that are interested, then you would probably switch the day. So they're just going to go over anything Python related, right? So learning best tricks, and, different frameworks, and a lot of different ways just to kind of up your Python skills if that's what you're data science in. So maybe if they get like a show of hands of people that are like, yes, I'm interested.
Where's it at?
Just down the street at Saltstack.
Okay.
So like 4, 5, 6, 7, 8, 9.
You could even send out a poll to the data science like Slack and see. I personally am like after work, it's kind of like if before the time comes up, it's like, yeah, I want to really go to that. And I'm like, just go to that.
Yeah, it's hard after like a long day.
But I definitely, when I see that, I'm like, it's the same night. And so I definitely won't go when it's the same night. But definitely keeping it fun. That's cool. So I have a question kind of about that too. We would be open for, is 6 o'clock too early to do this? Because it could go from, we did it before, we waited a little bit longer, a lot more people than everywhere. But if we're just waiting for an hour and having a late dinner and you guys want to do it earlier, then we could also go on earlier. That sounds good.
So, well, pro and con. Pro, yeah, it's nice. Con, rush hour traffic.
Yeah, I was actually the distant vote when we came up before because I was coming from up north and it was like, you do it at 6 and I have to leave at 4:30 or something like that. But now I work here, so I'm like, yeah, let's do it at 5. It's 4:30. We don't get anything done. So, well, I'll think about that and just I'll make probably the change either this time or next time. Watching for that. So some of the stuff I've been in Slack now a little bit. The information in case people haven't seen it. They're further north on Saturdays. It seems like they're the Salt Lake data analysis, machine learning study group. Because that's like first for me. They're doing it weekly on Saturdays, and they're starting to go through the Andrew Ng, Coursera machine learning thing. So you can find interests. So if anybody wasn't aware of that, that's happening. So week 3 of the year or of the class. Okay. Yeah. So that, as I remember, like starts getting matrix multiplication.
It's like just regressions.
Well, I think it goes through like first week is introduction, then steps back, second week.
It's like does octave and then it does mobility or algebra.
So, can we get the recording sorted out?
I think so. I think it's working.
Cool. So I guess once we fix that's recording with your are you just gonna Slack out the link?
Yeah, it's on the Slack channel already.
Oh, right.
I just underneath the materials.
So we then come with you.
Yeah.
Oh yeah. Definitely we need to make
So
the
there's like
pizzas and also the location and
Something that.
hopefully we don't
Yeah,
make much of
yeah.
a mess. That's always nice. You don't do that. But Jane.com is an online marketplace, and we supply a lot of women's items like clothing, as well as home decor, baby goods, things like that. So it's a little plug if you want to send friends, family, or wives check it out and tell us how bad it is, then and what I should fix. And that's fine. Really good of us, good of James to sponsor these things. So great. So anything else? Good. And if you want to take us away,
utah.data.roku.com. Utah data, one word. Oh, there you go.
Some search. I don't know if you can see it.
It says, I don't know, is it this?
That should be, yes.
Okay, thanks. Oh, yeah, they get some that.
Okay, there we go. Yeah, there's a little bit of a lag, but I do. Am I still sharing my screen with you?
No, you probably need to join again.
Because it looked like it crashed. So I'm gonna go now. And let's see if we can do that now.
Want to have a good joke this year?
So then, thanks, guys. Just a reminder, we have a GitHub repo, or a GitHub organization, actually. So some of the repos, I've got it's pinned to the general channel. If you want to go to that and see any of the past talks or stuff represented there, and links to all the previous meetups that are all kind of like in meetup materials historically as well. But I believe there was talk of getting to, good resources and stuff like that. So that might end up there. I just needed to add my things. Kind of got from productivity and such. And that was just github.com, Utah-data-science. Is that me? Yeah, I think we got regrouped. So this is growing pain. Sorry, guys. This is the first time that we're trying to record the screen and live broadcast it on YouTube. So this is, not only is it really fancy, it's also a little bit complicated. Yeah, so turn down the volume so see if okay. And if you're watching weeks from now on YouTube and you get like an echo effect, I'm sorry. But the same thing happens on my phone, so.
It's in the Slack channel.
I'm not going to replace my
Under Meetup materials.
Let's see here. Let's see if I can just bring this up. Okay. Ooh, and that's kind of washed out. That's okay. We're going to hit the high levels. Okay, so what I wanted to do for today's meetup is make sure everybody has a local install of Postgres. Not only is Postgres really awesome and powerful, they make it pretty easy to deploy on a local environment if you've done that already. And maybe you're at a point where, hey, like I only want to spin up a Postgres instance if it's within Vagrant or if it's on like EC2 or RDS. That's fine. You're probably already at a point where you can point to your database endpoint, load in files, and then pull them back out with whatever service you want. But for today, well, and maybe we can just get a show of hands, who's
who's familiar with Postgres, at least from the point of, hey, I've installed it, I've run it on my local machine, and I feel comfortable enough to do it. Somewhat. Okay, so this won't be like too far off. I mean, we've got a few hands. And then I see kind of a mix between Mac and Windows, or at least PCs. So if you're on Ubuntu, then you're in luck because the steps are almost identical. If you're on Windows, then it's actually even easier, but you might lag behind just a couple steps. But I'll get everybody on Windows started. Essentially, you'll just want to go to this link is fast. Let's see if I can tease this link out. PostgresTutorial.com, install Postgres.
Like Docker?
And I'll just post this link real quick to the Slack.
Takes all the configuration.
And while the announcements were being made, I also posted a few polls. So if you're going to get sidetracked, might as well answer those polls too. For the time for the meetup, and then also for the whether you want to go to the Python meetups on the same days as well. All right, so let's switch back and forth. That's great. Okay, so go ahead and step through some of those. It's really easy for Windows. You just download this exe file that runs through the installation for you. And then it kind of does some behind the scenes services, starts your server, spins up your database. I'm pretty sure that now in the newer installs of Postgres, they've kind of gone away from creating the Postgres user. And correct me if I'm wrong, but I'm pretty certain that now they're looking at the username that you're logged in as on your machine, and they've already done some of that. So it makes it a little bit easier. So let me know if my walkthrough is not up to date. I'm going to see if I can get this format that was a little more friendly. Okay. So you can't really tell. There are actual code snippets, but again, I think you can't exactly tell. Okay, so if you're on Mac and you use Homebrew, then we can follow this verbatim. If not, there's really a small difference. And it is, you probably just don't want to use terminal to install. You just go to whatever binaries download there is for Postgres and just GUI. Yeah. But I find Homebrew is kind of the best way. I know there's a lot of Anaconda fans out there, or Conda install, and using that type of syntax and package management, or especially for Python and Py environments. I've actually stopped using that because I just find that they compound how many binaries you have to use for every environment. I don't know. It seems like after I install my Conda environment or Anaconda, I tend to run out of disk space a lot faster. And I could be wrong about that, or maybe I don't have the right options. But Homebrew just seems to work really well. And I don't know if I have the wrong expectation as to how many will actually have this running by the time I move on. But we're actually going to get to a point where we're going to just open it up to kind of not like group work, but like, hey, let's test this out on our own. So I'm going to keep moving if that's all right. And then if you have questions about these steps, by all means, just raise your hand and let me know. Once you have Postgres installed, it's going to run the server for you. It's going to be at localhost:5432. And you should be able to access that. If for any reason it's not, you can use Brew again to get your services. If you don't have that installed, then you just can install Brew services or Homebrew services. And then you can start using stop Postgres, start Postgres, or restart Postgres. There are other utilities that you can use. Umber just kind of abstracts that for you. And then same thing if you're within a Linux environment, you can essentially do the same thing once you've installed. And I guess if you're using just Ubuntu desktop, I don't know if you need app yet. You might just use app. I've only used the server, so that's why I'm using app yet in this instance. But then you can test to see if it's running with this command, and then if it's not, then you can use PG as Postgres. They have their own control file that you can use, or file program command line tool. Okay. So and this was posted to the materials. So if you have to reference it, go ahead and go there. I know I tried to make it as easy to read as possible. Because it can be a little bit complex just getting started. For example, once you have this installed, unless you're on Windows, you will have a PSQL environment that you can terminal into. Or basically you start a shell within Bash, and it's for PSQL or Postgres. If you're on Windows, then you just use pgadmin, and there's a little button in their GUI that you can click on, and it'll actually open an emulator for that same terminal. So the commands are going to run the same no matter which environment they're in. If you're trying to run SQL from an actual file that you save on your computer, there may be some nuance to how you write your file path, as that's usually the case between Windows and Unix kernel machines. But that always seems to be trial and error, even if you think you have the right forward or backward slash. Okay, so I'm just going to go ahead and so I have here some notes how to add a new user. So if it is the case that they set up a Postgres user and you try to log in and they're like, hey, we don't see a username for, or a database for your username, that's okay. Just instead of using PSQL with no options, just use PSQL Postgres, and that should try to shell into the database that was created. And then there's a few other things to try in this small tutorial. The first thing I like to do is I like to set up a schema that's on my personal database. Even if I am just sort of testing stuff or doing things ad hoc, it really helps to keep things separate the further you get down into what you're trying to accomplish. Whether that's an entire data model and it's very and it's complex, or if it's just, hey, these are just a few CSV files that I needed to review for work. It always tends to keep things separate and clean. Okay, so from there, I'm actually going to jump into what data I have for today. Let's see. I don't want to download our package. So I'm not an avid runner. I started running a couple of years ago, and in fact, I think I hated running until I started actually doing it. And this should open up. It's like reading. Everybody loves running songs. So. Okay, so this might be the best way to do it. But I saw this image online of somebody viewing like the route that they ran, and it was actually really cool. Like, it wasn't cool in the sense that, hey, you could actually plot this because we know you can plot that. It was really cool in the sense that, hey, you can almost like turn this into art on your wall, like in your house, because the density of the lines depends on how often you run that route. You can change your alpha so that it's either really dark or really light, depending on how often you do run the route, which just overlaps. And then you almost get like a view of the streets without actually having the streets mapped onto the map. And there's some tweaks, right? In terms of visualizing this, I felt like this was just like a good data set, a rich data set to kind of play around with. But you can tell it's it's in a raw format. I mean, I don't even have like how fast I was running at any given point. I just have latitude, longitude. I do have elevation. I'm not sure if that's necessarily going to be in like the final visualization, but I thought it was kind of awesome to have a timestamp for every single one of these. Index in this case. So this is a standard. This data. This isn't a standard. This is parsed from the actual .gpx file. So GPX is essentially an XML file. So if you're not familiar with XML, it's almost like HTML. It's just a markup, but it's specifically meant for data schemas. And so this is a kind of a taste of what actually exists within these type of files. These are considered semi-structured files because they do follow a pretty routine structure. But they're not in like a table form or a relational database format. Although Postgres does have an XML store, they have a JSON store. And if you didn't want to do anything to parse them, I believe you could store them and then query them out of them. In fact, parsing these is pretty trivial. But this is what the data looks like. So just to kind of give you an idea, there's not a ton there. And then in R, I'm just going to hide this console. And these, I'll post these on the material as well. It was actually really like, that's the parsing. That's the entire parsing. It's really straightforward. I used a few libraries, one of which brought over GPX. So there's already pretty much a parser library for this type of file. And then I iterated over each file, gathering the location. And this location is just, it's like the observation number within each individual activity. So if it's a run, then I'm going to get a location I for every second or couple of seconds that my GPS is being read. So every once in a while, it'll skip a second. You don't get exactly on every second marker. But you'll never have two of the same second, which is nice. And then file is just the file where it came from. Which file is actually being read in. That usually has a date in it. Index is just a counter of how many files I have. And then the activity is always running because I don't swim yet. I don't really bike unless I'm commuting, so I'm not interested in how fast I'm commuting. I'm actually usually trying to go at slow enough speed so I don't get there sweaty. And then lap more, elevation and time. And then there's a little bit of cleanup, not a ton. And again, this is basically just moving things from character or from factors to numeric. And I know we've been over that before, and that's something that we would do. And then I saved it as a CSV, and I've also saved it as an R data file. And the reason why I chose this data set is one, it's readily available, and two, I think it'd be a really great project to rebuild a dashboard in terms of, hey, like if I'm thinking about this from like a coaching standpoint, do I really want to see the exact same dashboard that I see in the Strava app online, or do I want to see something that's specific to me? And my thoughts are probably not. They're experts. They probably have a pretty nice dashboard already, but why not give it a try? And I really wanted to see if I could make something that looked like art to kind of hang up and print. And that's because I think it's kind of old enough. So I like visualizing stuff. So I wrote it out to CSV so that I could load it into Postgres and then manipulate it. So after creating a schema, it's It's just really straightforward syntax. Create schema. I called it running because it's only going to include data that I collect from running or some other type of activity. The nice thing is once you're in this Postgres shell, actually, it's like, it's kind of small. So. So one thing about the SQL is that it is a little complicated at first if you haven't used it, but they do have this little help where you actually go through it and look at all the commands they have. We actually have quite a few to bring back a lot of metadata that you typically think of from your beginning. You say, well, like, you know, what database am I actually connected to? Like, for example, if I were to just say, let's see if that's yeah, like, so \DT is supposed to give you a description of tables that exist, or relations as they call it. But in fact, it doesn't really it doesn't give you everything. You actually have to set path. Set path. Oh, no, let's give this a try. I want to include the schema that I created in the path so I can see tables that I created. It's not parameter. Well, it's not for that either. All this stuff like that. But anyway, on the surface, there are a few things you have to set up before you start working. So you can see, otherwise you can do this, running, and then it'll actually give you the name of the tables that you've created inside this schema. So again, just / question. We'll give you all of these in a nice view. Just for me, I typically have to go over this a few times as I start to use. Oh, I know it is. It's either underscore or underscore. Let's see. We'll figure it out. Okay, so the next step that I took was to actually create the table. So in SQL, and I'm sure a lot of you already know, in SQL you have to create a shell for your table, or just like the actual create statement before you start populating it. And I know that's not like an absolute. There are instances where you can introduce dump data into SQL, but for Postgres and for our use, the create table statement is going to be what you want to use. If you're not using the public schema, then you'll have to have the syntax would be schema.table, and the table is the rename of the table that you create. And then it just looks like any other create statement from MySQL or I guess not SQL Server, but for the most part, it's just SQL at this point. And just like any other create table statement, you can create comments. You can alter the table in other ways. Things that are going to help you in the future. And then what you want to do is copy from. And so here's what you're doing. You're saying, I've got a file, or I've got basically a bunch of text. And it's going to come in this pattern. So the first thing it's going to be is this. Those are all names, like column names that exist in the table already. Pretty straightforward. If the file you're loading in is in different order, then you just rearrange those. And then you say where it's from. You give it this, the location of your CSV file, delimiter comma because it's CSV. I don't know if that's actually necessary. If you have a CSV here, I've always used it. I have no question it. And then header. If you don't use header, then the first row will be treated like observations. And if you have numeric declared on the new columns, it will probably throw in. Okay. So that should be pretty straightforward from there. Basically, that's as far as I'm gonna like get it. Other than I guess I do have a few scripts here to like actually get a difference in time, because honestly, that's pretty useless. The stuff in R. Like, what am I going to do with just data that looks like this CSV? Like, to the extent that you could actually use it, there is this quick little plotter that I have to run this whole thing. Anyway, I'll add this as well. But in the end, all it does is I know there's a quick way to get to your like working directory. Anyway, so the actual images that this creates is what they look like, and let's kind of go through them because they're actually kind of cool. I like them. So I don't know if anybody recognizes this little piece, slice of heaven. Oh shoot, you can't see anything.
Hello.
Yeah, I've only actually been running once. That's what it's fun. Let's see if I can. I can't make that any heavier. Let's see. Let's see if I can get this. Yeah, the colors on this projector are not so great.
Oh, we're not supposed to guess where you live?
You can guess where I live, but that actually, so part of the script, what it does is it clusters. And it set the start of the cluster at 5. And I was just like, I don't think I've ran in 5 different geographic, like distinct geographic locations at all. But it actually, the algorithm picked 6. So I was like, hey, that's kind of cool. Like I've been running in 6 different locations. But this is Provo Canyon. I don't know if anybody guessed that. I should have asked. And the centroid is actually usually pretty close to where I start my runs. So yeah, I guess it's not where I live actually. It's where the office I work out of. But yeah, so you can see like this is 800 South. This is Lake Ridge Middle School. So there's a little what's it called, track. And then here's just like all those weird little parts of Provo Canyon. And I mean, so here's Squaw Peak, back through there, and the Bonneville Shoreline Trail. No, this isn't quite at the canyon yet. This is Squaw Peak Road. I don't know what. That's probably the Shoreline Trail as well. This is the river bottoms. Quite a few different paths you can take down there. But this is pretty useless. Like this is honestly, like I said, it's art. Like that's the only thing I'm going to want to do with it. But you guys have to tell me what to do with that data in order to get to something that is useful, and you have to also devise something that is useful, right? Like I have lat and longitude, latitude, longitude. I have it for almost every second, but not quite every second, right? And I'm pretty sure those aren't milliseconds. I'm pretty sure those are seconds. So, I mean, we're talking about like Newton's calculus, right? Like you're just taking straight lines between your path and estimating velocity. So we can't even derive something or use a real integral in this case. And then I've got some elevation. So if you really wanted to take like a 3D space, change the distance, you could. Nobody's going to hold you back. But how would you set up your data table to give you something useful? And maybe let's take it one step back. What would be useful if we actually had, whatever, like you guys, who runs or who does anything physical?
I breathe. Just like
Yeah. I mean, yeah. If you want to know like how often you're breathing, given the activity, no, like if we think about it, what do we want in the dashboard? We want to know maybe speed, right? So your average speed, or maybe like a pace, like a miles per hour. You're going to want to know possibly if you like crank down your speed like on hills. Like if you're gaining altitude, like how much slower does that change? Like how much slower do you run as opposed to maybe staying flat? And is there a way to optimize? Like I have a crazy theory about running, and that is if you attack hills, I have a feeling that if you slow down on the downhill, like let's say you have an average speed going up a hill and an average speed going down the hill. The paradigm is to take it slow on your uphill and then cruise pretty quick on the downhill. My thoughts are that if you were to invert those, and it's maybe impossible, I feel like when you're done with that hill, you'll be less tired. Every time I've ran a race, I've increased my pace a slight, like smidgen on a hill. And these are gradual hills. I'm not scaling mountains because that would be nearly impossible. But I feel more energized. But is that really true, or is that just something that's psychological, right? Well, the data can help us answer that. But what do we need to do, or how do we need to clean it up in order to visualize it in either a dashboard or in some way?
So the first thing would be to get a distance calculator so you can figure out the distance from latitude and longitude between each of those coordinates.
Yeah, they're called minutes, right? Once you get to the decimal place.
Yeah.
That was my first question. Like, how does that translate to feet?
Yeah. If you get runner's weight in there, you can like put in total energy spent.
Okay.
And
so if you had my weight, is what
yeah.
you're saying?
Yeah.
Because it's force times mass, right?
Yeah. And so then you do comparisons between runners like, well, you're moving slower, yeah, but you're also burning longer.
I'm 88 kilograms. What does that really mass you? But no, my weight has changed over time. So yeah, like my uncle is a triathlon athlete. Well, in fact, I'll say this: like he is like, well, I won't say this because it's on YouTube. He is an extremely focused individual, and when he does something, he does it 100%. This is my wife's uncle, by the way. So he says he does triathlons, and anybody that's doing triathlons, you're like, okay, like yeah, like you'll run a sprint or this or that. He takes first place at triathlons, and he's like pretty close to his 50s. He's just an amazing athlete, and these are amateur triathlons. He's not a professional. He doesn't have time, and I don't know if he really wants to do it, but yeah, he's doing fairly well. I don't know if he feels pain, but he told me that for every pound that you can lose in weight, you shave 5 seconds off your mile time. Which I'm just like, yeah, you can do that by just speeding up, right? Like just thinking about it. Maybe you just say, I'm going to be a little bit faster in this mile time. But yeah, when it comes down to it, like if I drop 20 pounds, I can expect to lose 100 seconds off my mile time, which I believe I've fluctuated a lot. So maybe that's it. It's a really good point. We could bring in there's another app that has that metadata. Because these apps capture your weight every once in a while, like every time you tell it to sync. But if you have like a Wi-Fi enabled scale, you can capture that. What else? Like, how are we going to actually transform the table though? Like, how do we actually get a change in distance? Because I'm saying like every second I'm moving, right? Yeah, 2 points. Okay, so, and in SQL, how do we do that? What's that?
The hypotenuse.
Okay, so we can take the hypotenuse. If we add in that third dimension, that's going to be the thing to do.
There's functions for this, like distance functions built into Postgres.
Okay, why don't you trace down that one? Because I actually wasn't going to use one. I was just going to subtract.
So it's like where you're at in the country, because the distance may be different in miles. You're up higher than it is lower.
Yeah, the distance changes.
Well, it's flat because of the curvature.
That's right.
Yeah. Let's say that that's a small difference. We're talking about Newton's calculus here. I'm saying I don't care if I'm going around a corner and I do it in less than a second, or maybe in less than the time frame between the two snapshots. I'm going to draw a straight line, and I'm going to say that's good enough.
One thing that might be interesting to do to help actually, like a lot of times when you look at the dashboard for your speed, like on Strava or whatever, it's like all over the place because it's such small increments.
Yeah, it is.
And so it might be interesting to like take averages, like group the data into longer time frames, and then take distance measurements like every 10 seconds or every 20 seconds.
Okay, so we're thinking aggregation, right? We're thinking averaging, but how do we take the initial data point? Because we still have to have that in order to aggregate it up. So let's say if we do want to have a 3 second interval or a 5 second interval, we still have to have the singular averages or the singular speeds, right? So to actually make this happen is you have to line up a row and the row after it, right? And you do it like just a subtraction. So you just take the difference. Let's check.
More than that here.
Yeah, so the first thing that I did, and I'm kind of crazy about this, is because it can come back and get you. I wanted to make sure time was a timestamp as opposed to just a string. And it turns out it passed that test really well. Even though, if you remember the raw data, they had like little Z's and that actually might be a time format. Oh wait, you don't know because you didn't see it all.
Yeah, that is time format.
That doesn't. There we go. So I have this T and Z, and so people more familiar with time formats may say, "Oh, it's not a big deal. That's exactly what it is." I didn't know that. But then one thing that's nice about Postgres, or SQL in general, is your ability to join on itself, join yourself on the same page with a lag. And so I actually, because these aren't technically 1 second intervals, I also took the difference in the timestamps. I want to take the difference in the timestamps, not just the difference in the locations. So I don't want to just treat everything as 1 second, even though I'm sure that difference in the discrepancy would be really small. I wanted to base it on something that was actual, so you can see. And one thing that I'm doing as opposed to just looking at one observation difference, I'm actually looking at a 4 observation difference. So I'm subtracting lag 4. And the reason why I'm doing that is because I do feel like there's too much jitter. You can't get a really good estimate because the GPS is going to be off by some factor. And I wanted to minimize that or kind of mitigate that. If we look at this, I mean, we've only got So I guess that's quite a bit of precision, actually.
Not necessarily. It is the size of the world, so.
Yeah. Well, no, I mean, I was thinking we got 3 to 4, we got 6 or 7, really there. But even still, like you're gonna have some rounding error between these. And in reality, look at this. In 1 second, or about 1 second, I only traveled the longitudinal distance of whatever that is. That's pretty pathetic. You think I was faster? Why did I turn it?
Is this data on the slide?
This data is on slide, yeah.
Okay.
Yeah, so everybody's gonna know how fast I am. And then you can see elevation change. So there are functions to do this. Like there are SQL functions to do this. There's also R functions to do this. Sorry, I stuttered. But I find doing and building just like a really like kind of a raw solution helps you think through it, and then also it makes you more appreciative when you do find like a built-in function. Because you can validate, see if it works. So going back to this, you don't have to do a for lag, right? Because when I'm joining back on itself, I'm just saying everything in my repeated table P, just join on the observations -4. And maybe you want to do just 1 or 2. I feel like if we're going to be doing kind of like a Newtonian calculus and just take like straight lines between points, we might as well make those lines a little bit longer. They get a better estimate for the distance over time. And that's kind of the beginning. So once we do that, we're also going to want to take the distance, and I didn't include them in here. Like, notice I only have these 2, and I didn't even subtract them, right? But you could do a date diff and then extract seconds or extract milliseconds. I don't think milliseconds is going to be part of this, but maybe it's just not being displayed in format. I don't know. It could be stored. But anyway, you can extract the seconds, and then that's going to be your divisor, right? Your divisor for your speed calculation velocity. And the nice thing about having now a schema called running is you could store that new table in that schema, right? You're building this new table, it's going to be part of some analysis that you're doing. And generally, you like to have like a data table or a data model for each graphic that you're building. So the data that you need for a bar graph that just displays your velocity or your speed over time, like the time intervals that we've spoken of, like over maybe a 5-second interval, so throughout the duration of the run. It'd be pretty simple, right? You find the speed, take your interval, and what's really nice with Postgres is there's window functions. So once you have an interval, all these minor seconds within the interval will be found within it. So you could syntactically just tell it, hey, don't look at the minor seconds, look at the big ticks. And you can define it either within a window, or you can create a new column on a data, like an actual table, and then you can create a window on that. And I know that's just kind of like long waiting right now, but you certainly, like, I would just invite you guys to do a little bit more digging. And yeah, so this is as far as I got, which is kind of embarrassing, except we had a few things this week that just made it a little bit impossible to give more time to this. But it will be, I think, more than anything, like, my goal is to have kind of an R shiny. I don't know if I'll use anything outside of SQL for it, but if I were, dplayer would be really easy to use and straightforward in this type of implementation. But yeah, like, any questions? I don't want to say any questions, but any questions at this point? Because we really could just turn this into a working session. Just crank
Is this the raw data from your watch? The CSV file is all the data. There is no other data.
So this is 148 runs between the time I started running and now.
Okay.
And I haven't ran it like, well, other than on a treadmill, I haven't ran it in a while. And that's just, we had a baby and a few other fun things. Yeah, it's all of it. This is all that Strava gives without premium services. So there are other data. There are other data from Garmin I could bring down, and then there's MyFitnessPal, I believe, that I could also pair based on date to bring in the food I've been eating, what my weight is, and it's adjusted just as I input it. So if I don't like what's on the scale, I may or may not put it in the app. If I'm really happy about what's on the scale, then of course I'll tweet it out or whatever. But there's a little more bias there.
Yeah, some of the watches you can actually hack them to get the raw GPS and NEA data. So things like how accurate the GPS was at a particular moment in time or something.
Yeah, like there are a lot of things that I see. In fact, I believe there's a few apps you can download directly to the app that kind of give you that hack, and then they output your data, like whenever you get back from your run. I'm still waiting for Garmin to fix the heart rate monitor so I can turn it back on because it just freezes I don't know, sometime in December they updated the software and it just, my watch went from, maybe a week of battery to a day and a half. It just thinks that I'm running constantly. Which is odd. Hey,
Just trying to pad your stats.
Yeah.
Running.
Yeah. Well, no, I mean, it doesn't think I'm like in the middle of a workout, but the heart rate monitor is running like on the millisecond. It's just constant count. So, yeah, we'll see when they can correct it. I'll turn it back on. That's pretty much it. You can tell like it's kind of a playground. You can really get fancy with it. SQL, I do as much work in SQL as I can. I don't get out of SQL until I have to, because it's so easy to manipulate data. It is the language for data. It is the language for data on relational databases. There are several applications of which it may not be well suited. But yeah, I try to do as much as I can. In fact, if you're using SQL through Python or through R, then you can create a template query or a template just about anything and interject into it really easy to use macros that then will either loop. And I know like for admins, database admins, they do all crazy stuff with partitions and different things, and sometimes they're really upset about queries that you'll run. But there's so many ways to optimize it. It's a lot of fun. The other thing that I would say is like a window function. If you want to see the syntax for that, I'm not the best at like on the fly, but I'll just say you're selecting a bunch of stuff. And then there are window functions, so we'd say something like, and then you'd say traditionally used just like where from, Strava GPS. And then you have, you want to do your first value over a window. And then you define what your window is. So window, W, I think this is the right position by, and then here you want to include index because that's the run. You don't want to know what the first time is unless you can partition by each time you actually start out, you start running, or you start your activity. Otherwise, you'll just get either one value or you'll get too many values if you partition by too many things. So you wouldn't want to partition by time, right? Partition by index, and maybe if you do have like biking activities, maybe they're indexed separately. Meaning the index isn't exactly unique. This just isn't an index that Postgres created, I created it, so that's a little confusing. So I apologize. But you can do this as well. And if activities and index create a unique pair, then this is the right way to do it. If they don't, then it really doesn't matter anyway. Like if activities is the exact same value down the entire column space, then it doesn't matter. It's not going to slow you down. And if it doesn't, no seconds. And then what you do is you order by. And I'm sure that's not exactly right. In fact, it's almost right. Got to check it with like a quick Google search if it doesn't work automatically. But what's a little frustrating about window functions on Postgres is that if you do last value, and you actually have an entire table. So with this query, because I'm saying select all, I'm actually going to get the exact same table I had before. I'm just going to have an extra column that has a single value down the column space for each index or for each item in the partition. So for each run and activity combination that I have, index activity combination, I'm going to have a first timestamp. So that's going to be when I started that activity. If I do last underscore value, that's actually not going to be true. I won't have a last value down the entire column space. Hence the annoyance. I won't have the actual true last value until I get to the last observation in my partition, which is in part how they optimize Windows, is that they're technically looking at it in the way you do like a search on like a max or a min. So the window function is actually not looking at the last value per se. It's just saying, hey, here's the last value given the observations I've read from the index until now. Okay, so it says, is this the last one? Well, yeah, it's the last one because it's the smallest, I guess, or sorry, it's the greatest timestamp. Okay, you skip to the next level, and that's not the case. The greatest value is the value of the current observation, so it's gonna throw that one until it gets to the end, and then it's, by virtue of being the last one, it's the last value. So what I do is I order by this variable, but I do it descending, and then I do two first values with two separate windows, and it's a little bit less efficient, but that's kind of how the algorithm works. It kind of has to be if you're going to just get one observation. Now, if this table doesn't have anything, it just has one observation per partition, then you should get the last value, but you just double check that it's not doing there. But yeah, so that's how the window functions work. I think with window functioning and a few built-in functions, you can get to a solution really, really easily with this. I don't know if anybody's overly jazzed to go out and find out how fast I am. Surprise, I'm not that fast. But if this is something that you want to do on your own, and hey, maybe you've been looking for ways to visualize geographic data or spatial data, there within this code, there's a library that I found was a little bit useful. It was really buggy because I had to be on the absolute newest version of R, but the error said, hey, we don't have a library built for the version that you have. And so it's kind of weird because I was like, oh, so maybe it's, maybe this is a deprecated library or something that doesn't function on the one that I had. I thought I was in the newest copy. And so I actually went back into time, trying several different binaries of R until I just decided to screw it. And then I updated to the newest version. and on a whim decided to try it again and it worked. So, and it's called Maps. So if anybody's used the library Maps, it's one of several libraries that can work in. And there's a few that I gave a go at. I have another one. Let's see. May not have been on where it's at. Where it actually called it. Okay, it's Map Project or Project. It's projecting longitude and latitudinal data onto the actual map. So you can bring in other elements that carry the same coordinate. Let me just open it real quick and see if I've got it. See, this one didn't work at all, but it's really interesting because it ties into the Google API. So you can actually give it a search, and then it'll print a map that's centered on that search item. And you can give it the scale or zoom option. And then you can also give it this OSM argument. And basically what it does is it just creates kind of more of a transit-y look. So it color coordinates the streets based on public transit. So it gives you a little bit nicer color or view of your map. A little bit more cartoony than the other option. The other option looks very professional. Not to have sources OSM if you just leave it as default. But when I tried these, the API failed. It gave me a 404 error. And so I wanted to do a little bit more research. But the actual packages that were required were just ggplot2 and ggmaps. So ggmap, I think, is it's basically used for Google API, Google Search API. And so I wanted to do kind of a reverse lookup for that as well. Give it a lat long and see if it would come back with the actual location. Didn't get too far into that. And this was a super quick aside once I discovered that it didn't matter. And then had to revert back to that project to get the plots. Yeah, so that's pretty much all I had, or all that I have prepared at this point. Again, I really feel like this is better served as we progress through. I know dplayer, I don't know how to say that. Is it dplayer? Dplayer, okay. I'll think of players. Dplayer, Shiny, and then ggplot2, I think. And in reality, like, it's really going to come down to what I always have to do first is I kind of have to draw the widget that I'm building, like the plot. Like, granted, I didn't go and draw the streets and all of my running routes on this one. That was kind of straightforward. That's like the raw data being plotted. But if you want to do some analysis or have some graph be part of a dashboard, I always have to draw it out in wireframe. It gets me into a better mode to think of data in that sense. And then it makes the manipulation of the data a little bit faster. Just as a tip, like, I don't know where I read it. It might have been like some agile book, but it says always to design first and build later. So just wireframe stuff. Yeah, that's
Make sure to grab a pizza that's wings. And yeah,